ننتقل الآن إلى سؤال 25. هذا السؤال جدا مهم وأنا حليته طبعا مسبقا. هذا السؤال بيحكي لنا a particle is moving clockwise in a circle of radius 1 meters. At a certain instant, the magnitude of its acceleration is a equals to 25 meters per second square. And the acceleration vector has an angle of theta equals to 50 degrees with the position vector as shown in the figure. At this instant, find the speed v of this particle. And then we want to find v. Right. And we should know the following. We should know that the given acceleration is the total acceleration. So this is the magnitude of the acceleration. As you can see, this is the vector here. طبعا why is it in that way? Because if we draw the centripetal acceleration, it will be pointing from this point towards the center of rotation. Always the direction of the centripetal acceleration is from the parameter or the point of interest towards the center of rotation. Let's just make it red so you can see. What is that? This is basically the centripetal acceleration. But as you can see, if this is the tangential acceleration and this is the centripetal acceleration, between them we will have what? We will have the magnitude of the acceleration. طبعا using the Pythagorean theorem we can find A. How we can find the centripetal acceleration? طبعا why do we need it? Because we want to find V. الآن, if we can find the centripetal acceleration, then we can simply find V. Why? Because the centripetal acceleration is equal to V square over R. طيب جميل. Now, how to find the centripetal acceleration? If we go to this drawing, we will see that the angle given here is between the centripetal acceleration and the vector A. So basically, we can say that A sub C is equal to the magnitude of the acceleration multiplied by cosine the angle. طبعا why? Because we always know that whatever makes the angle takes the cosine. مين عندنا صنع الزاوية؟ هل هو انصنعت الزاوية مع الواي اكسس ولا مع الاكس اكسس؟ لا، انصنعت الزاوية ما بين الواي اكسس مع الفيكتور A. طيب مين موجود عندنا على الواي اكسس؟ موجود عندنا السنتريبيتال اكسلريشن. فدائما اللي بيصنع الزاوية باخذ الكوساين. So we start by saying بأنه السنتريبيتال acceleration is equal to the magnitude of the acceleration multiplied by cosine the given angle. Then we substitute the values. Then A sub C is equal to the magnitude of the acceleration, which is 25 given in the question, multiplied by cosine. The angle is also given as 50 degrees. If we use the calculator, we will get 16.07 طبعا unit meters per second square. Please do not forget to always convert from radians to degrees whenever we have degrees, and to convert from degrees to radians whenever we have radians عشان ما يطلع معنا الأجوبة غلط في الامتحان. طيب, then we write down the equation of the centripetal acceleration. It's A sub C. It's equal to V square over R. Now we can find V basically by multiplying both sides by R and then taking the square root for both sides. So we say V is equal to square root of R times centripetal acceleration. Let's substitute here. V is equal to the square root of the radius of rotation is given as 1 multiplied by A sub C, which is found to be 16.07, and this will almost give us 4 meters per second, which is around 4.001. This is almost equivalent to 4 meters per second. And this is the end of this question. طيب, ننتقل الآن إلى سؤال 26. الآن question 26 شو بيحكينا؟ A car accelerates uniformly from rest. بيحكينا from rest معناته دائما omega node is 0 and the V node is also equal to 0. And reaches a speed of 22 meters per second. This is the final velocity it reaches. The V final is 22, or let's not write it down because we did not write it previously. Now, in 9 seconds, this is the time taken. جميل. The diameter of the tire on this car is 58 centimeters. This is the diameter. We want to find R. So R is equal to 58 divided by 2. which is equal to 29 centimeters. Let's start with the first part. A. Find the number of revolutions the tire makes during the car's motion, assuming that no slipping occurs. الآن, to find delta theta, which is basically what we want to find in this equation or in this question, we can use the following equation. What is it? It is basically omega bar equals delta theta divided by delta t. So if we find omega bar, which is the average angular velocity, then multiplied by the time given in the question, we can find delta theta. طبعا, the answer will be in radians. So we have to convert to revolutions. طيب, الآن, let's see how we can find omega bar. Omega bar is equal to omega final plus omega naught, omega initial divided by 2. This is the average angular velocity. طبعا, why did I use this equation? Because in the second part, طالب لنا what is the final angular speed, so we can use it again. طيب, how to find omega final? Omega final is basically equal to V final divided by R, which is given in the question as 22 divided by the radius of rotation, which is 29 centimeters. Now convert it to meters. How? Divided by 100, so you get 0.29. Right. And I'll take the value as is. Let's substitute this value in the question, or let's write it down. Omega final is equal to 75.86 radians per second. And now let's go back to this part and say omega bar, which is the average angular velocity, is equal to 75.86 plus omega naught is given as 0 starting from rest, divided by 2, and this will give us what? This will give us 37.9 radians per second. جميل. Then let's go back to this equation here, and we say now delta theta is equal to omega bar multiplied by delta t. So delta theta will be equal to 37.9 times 9 seconds. So we have here 9 seconds. Let's just use the calculator, sorry. Okay, it's not here. So we say 37.9 times 9, and this gives us 341.1 radians, and this is the answer. So we say this is equal to 341. طبعا the answer has to be in radians. لأن هو طالب منا in revolutions. What do? We say delta theta, the angular displacement in revolutions, just divide this answer by 2 pi. So 341 divided by 2 pi, and we get around 54.33 revolutions. And this is for the first part, this is A. طيب, نيجي الآن إلى B. طبعا, as I told you before, we already found B, which is the final angular speed of the tire in revolutions per second. طيب, how to find it in revolutions per second? We already found that omega final is equal to 75.86 radians per second. How to convert this value to revolutions per second? In this case, we will do the following. We will say, just divide the number by 2 pi to get it in revolutions per second. So this is equal to 75.86 divided by 2 pi. And this is in revolutions. طبعا, if we do the calculation, we get around 12.07. This is per second, sorry. Revolutions per second. And this is the end of question 26. ننتقل الآن إلى اللي هو part 8 or question number 8 in the exam. The main learning objective of this part is to identify that the centripetal force necessary for circular motion can be provided by different forces such as the force of friction, tension, gravitational force, Coulomb force, or the normal force. The equation that we will use is the centripetal force F sub c is equal to m times a, or the centripetal acceleration, which is equal to mv omega, which is also equal to mv square over r, which is also equal to m omega square times r. Let's start now with question 27. حكينا في هذا السؤال. Calculate the centripetal force exerted on a vehicle of mass m equals to 1500 kilograms or 1500 kilograms that is moving at a speed of 15 meters per second around a curve of radius r that is equal to 400 meters. Which force plays the role of the centripetal force in this case? طبعا كونه طالب منا centripetal force, we can use this equation directly. We say F sub c is equal to m v square over r. إذا بنلاحظ بأنه معطينا الآن هو فعليا الماس. This is the mass. We also have the radius of rotation of the curve, and we have the speed. So we just plug in the values in the equation, which is 1500 multiplied by v square, which is 15 square, divided by the radius of rotation, which is 400. And the answer of this will be 843.75 newtons. طيب جميل. الآن هو طالب منا which force plays the role of the centripetal force. طيب الآن if we draw a simple or a small free body diagram, let's assume that this is the car or the vehicle, let's say. And now let's draw the forces acting on the vehicle. طبعا ما حكينا بأنه في عنا banked curve، فبالتالي راح يكون عنا flat ground. So we have the first force upward and the second force downward. عبارة عن شو طبعا we will see. And then we have a force towards the center of rotation. Let's assume that this is the center of rotation, so I have a force towards this direction. طيب. Now I'll write down what is this force, of course. أولا we start with the gravitational force downward, which is equal to what? It is equal to m times g. And we have the force that is perpendicular to the surface of contact, which is the normal force. This is n. And what holds the car from skidding, يعني اللي هي عبارة عن شو؟ عبارة عن friction force. فبالتالي towards the center of rotation, assuming that this is the center of rotation, فبالتالي we have the friction force, which is the static friction. And in this case طبعا we only have one force acting on the vehicle towards the center of rotation, which is the friction force. In this case it will be the same as the centripetal force. فبالتالي طبعا if we continue, for example, طبعا we can just say that which force plays the role of the centripetal force, we can simply say that this is the friction force. طيب what if, for example, what if, let's write it down, what if we want to find the coefficient of static friction, mu sub s. In that case, we have, after drawing the free body diagram, we can say that the normal force is equal to the gravitational force. So أولا, summation of forces acting on the y-axis is equal to 0 because the car is not moving up and down. طيب, what forces do we have on the y-axis? We have the normal force upward, so it's positive, minus the gravitational force downward, so it's negative. So I'll write it down as mg or f sub g, it's fine. This is equal to 0. Send it to the other side and substitute the value of fg. So we get that the normal force is equal to m times g. This is the first equation. طيب, now we go to the x-axis. What forces do we have on the x-axis? We only have the centripetal force. So we will say that centripetal force is, in this case, is the same as the friction force. طيب, الآن let's substitute the values. We already found f sub c. It was found to be 843.75 Newton. Now what if we want to find the mu s? Just substitute the value of friction force. So f sub c is equal to mu s times the normal force. Don't forget that this is the friction force. This is f sub s. static friction. طيب, now we want to find mu s. Just divide both sides by the normal force. What is the value of the normal force? Again, from equation 1, it's equal to mg. So plug in this value in this equation. So what do we get? Get that mu s is equal to, divide both sides by the normal force and then substitute the value of the normal force from equation 1. So it's F sub C divided by N, which is M phi G. Then plug in the values. US is equal to 843.75 divided by the mass of the vehicle is 1500 kilograms multiplied by the gravitational acceleration, and this is equal to 0.057. Let's just do the calculation quickly just to make sure. 843.75 divided by 1500 times 9.81. So this is correct. Yes, 0.057. طبعا the coefficient of static friction is unitless, so there is no unit to write down. هذا بالنسبة للسؤال 27. نيجي الآن إلى question 28. In question 28, calculate the centripetal force exerted on a stone of mass m equals to 2 kilograms that is being swung at a speed of 6 meters per second around a circular path with the radius of r equals to 1.5 meters. Which force plays the role of centripetal force in this case? طبعا this is a question that is similar to the previous one. كتبته بس عشان نميز كيف احنا بنحدد type of the centripetal force in the question. So first of all, we start by finding the centripetal force. A F sub C is equal to m v square or r. طبعا again, why do we use this equation? Because we have the linear speed, which is 6 meters per second. Now we substitute the values, plug in the values. M is equal to 2 times v, which is 6. And don't forget the square, divided by the radius of rotation, which is 1.5. And the answer of this will be 48 newtons. Then we need to identify the type of the centripetal force. What type of centripetal force that plays the role of centripetal force basically in this question? We simply say that since we have a string and the stone is being swung, يعني احنا قاعدين بندور هاي الستون باستخدام حبل أو خيط أو string. فبالتالي we can simply say that since it's being swung, that means we have a tension force. So the centripetal force here is equal to the tension force, which is equal to 48 newtons. This is tension force. And the direction will be towards the center of rotation, always towards the center of rotation.